Okay, here is the 6-5 video again. Hopefully this time it all works out. So we're going to start with looking at the method of solving our linear equations and then the best time to use them. So for graphing, I think the best time is whenever you're given like maybe a word problem or a situation that requires you to graph, similar to the inequalities that we graphed in 6-7. But honestly, anytime you can graph it. It's just that we don't have, graphs all the time at our disposal. And so sometimes it's just as quick to graph by substitution or elimination, but you can graph anytime. Honestly, graphing and using Desmos online and typing in those two systems of equations is a super quick way to make sure that your ordered pair is correct that you solve for. Okay, so substitution though, best time to use when a variable is already solved for. So what this means is if you have like y equals or x equals, it's super easy to just substitute that in. That's the best time to use it. The best time to use elimination is when you have maybe like a common constant in front of your variable, or maybe you have nothing solved for. Kind of running out of room here. That's usually when I say to go for elimination. Okay. So we want to determine the best method and then solve. So on your homework, you're going to do the same thing. You're going to select either elimination or substitution and then solve it like normal. So I'm looking, I see that this y has already been solved for, 5x minus 17. So I'm thinking I'm going to use substitution here. That's going to be the probably quickest way to do this. Then I can plug in 5x minus 17 every time I see y in that first equation. So I'm going to copy it down right here. Replace the y equals with 5x minus 17. Make sure to keep it in parentheses there, and then I'm good. So I have 3x plus 2 times 5x is 10x. 2 times negative 17 is negative 34. That's equal to 5. So because my 3x and 10x are on the same side of the equal symbol, I can just combine them together. 3 plus 10 is 13. And write everything else down. I'm not changing it. But now I want to add 34 across the equal sign here. So my 34 cancels out. I'm left with 13x is equal to 39. And so now if I want to get rid of that 13 in front of the x, I'm going to divide it, and I get x is 3. But I'm not done because I need to plug that back into one of the equations. I'm going to plug it into the second one because that one has already been solved for y, so that's an easier way. All I have to do is replace the x with 3 because I know that's what x is equal to. I get 15 minus 17, so that tells me y is equal to negative 2. So my ordered pair is 3, negative 2. Okay, for this one, I'm looking, and okay, I see some common constants here. Remember, constants are the numbers in front of our variable, so I see I have 2 7s. However, if I use elimination, which is what I want to use, I'm going to write elimination. If I use elimination and I add things together, I would get a 3x plus 14y. That's not what I want. I'm still left with all my variables. That's not the point of elimination. Remember, I need to cancel one of them out. So I can do something very easily and maybe multiply one of the equations by negative 1, so that way it becomes a negative 7, and a 7 minus 7 then goes away, and that's why we want to use elimination. So I'm going to copy down the first equation the same way, and then I'm going to multiply everything by negative 1. That just means I'm changing the sign. So my negative 2x becomes positive 2, positive 7 becomes negative 7, positive 9 becomes a negative 9. Now I can add down. So I have 5x plus 2x is 7x, 7y minus 7y, that goes away. 2 minus 9 is negative 7. So I'm going to now divide by 7 everywhere. I get x is negative 1. Again, I'm not finished. I need to plug this back into either equation. I'm just going to plug it into the first one. So I get 5 times negative 1 plus 7y equals 2. Again, all I did was take that negative 1, that is my x, replace it in, because I know it's negative 1. So I get negative 5 plus 7y is 2. I now want to add 5 to either side. I get 7y is 7. So when I divide by a 7 here in front of the y, it goes away, and I'm left with y is 1. So my ordered pair is negative 1, 1. So we're using the same methods as before, but we are seeing which method is better. I'm not telling you. I'm not saying, okay, use substitution for these, use elimination for these. You have to be the ones to figure that out. Okay, so now let's look at the 2 word problems here. Yeah. And also make sure you have the word problems written down from the previous section, because the homework is going to be similar to these questions, the questions we did in the last section of notes, and I'll show you another example. Okay, so it says Jared volunteered 50 hours. He plans to volunteer 3 hours in each week. Clementine is a new volunteer who plans to volunteer 5 hours each week. We want to write and solve a system of equations to find how long it will be before they have volunteered the same number of hours. So when I start word problems, I always want to define my variables. And I can define my variables by looking at what my question is. That's what I'm trying to find. That's why we use variables, because we don't know what that number is yet. So we're going to find how long it will be before they have volunteered the same number of hours. So I can say x is how long, right? That's what we're trying to find. But now we need to think, how are they measuring that? How are they measuring this time? Well, we're talking about weeks, right? It says Jared volunteers 50 hours and plans to volunteer 3 hours each week. So we're trying to say, how many weeks do both of them have to work before they have the same number of hours worked? So we can also write this as number of weeks to be a little bit more specific here. I need 2 variables. So all of these word problems that we are doing this section are going to be requiring 2 variables and therefore 2 equations to be able to solve. So I need a y. And so this one's a little bit trickier, so I'm going to lead you down the right path here. But it says there's something else that's kind of being measured in this problem, and that is the number of hours that they worked. So we don't know how many hours they will work to have let me rephrase that. We don't know what that number of hours is where they're going to be the same. But we do know that the number of hours is going to be equal. So I'll say that one more time. That's kind of weird. We don't know what the number of hours is that they're working, but we do know that they're supposed to be equal, because it's saying how long, how many weeks must they work before they have the same number of hours worked. So that's 2 unknown numbers, but we know something about the y. We know that it's going to be the same for both Jared and Clementine. Okay, so now I can set up my equations. So I know they're going to be the same, so I can set up 2 equations with y equals, because they're going to be the same thing. One for Jared, one for Clementine. I'm forcing my equation to be set up like that, because I know y, Jared, for y is the number of hours, and the y for Clementine is the same number of hours. But they get there by doing different things. So I'm going to look up at Jared, and it says he has volunteered 50 hours. So I'm going to write 50. He has started with 50. Then he's going to work 3 each week. So we're going to add 3x. Because remember, x stands for the number of weeks. So that y is going to give me the total number of hours. Starting with the 50, that's our flat rate that we start with. We're going to add 3 times x, 3 per week. But with Clementine, she doesn't start with anything, but she's working 5 per week, 5x. So we have 2 equations now that I can set equal to each other, because we're saying y is 50 plus 3x, but we're also saying y is 5x. So I can set those equal by using substitution. Okay, so now I want to solve, so I can subtract 3x from either side. I get 50 is 2x, therefore x is 25, which is what we wanted to find. We wanted to find how many weeks, so it's going to take them 25 weeks to have worked the same number of hours. It doesn't say anything about how many hours they do work. We just need the 25 weeks. Okay, so the next one, it says we have 17 species of penguins. Tells us a little backstory about that. It says one of the smallest is the Galapagos. The total height of the 2 penguins is 169. The emperor penguin is 22 centimeters, more than twice the height of the Galapagos penguin. We want to find the height of each penguin. So again, I'm looking at what is my question. My question is I'm trying to find the height of the penguin. So I'm going to make my variables, x and y, the height of each penguin. So we're going to say x is the height of, let's go with the emperor. And then y is the height of Galapagos. Okay, so those are my 2 variables. I now need 2 equations. So I'm going to look, it says the total height of the 2 penguins is 169. So if I add x, the height of the emperor, with y, the height of the Galapagos, that gives me my total of 169. Then it says the emperor penguin is 22 centimeters more than twice the height of the Galapagos penguin. So we're going to say the emperor penguin, which we name that x, is, remember when we see the word is, that's our equal sign, 22 centimeters more than twice the height of the Galapagos penguin. So I'm going to say 22 plus 2y, because I'm adding 22 more to 2 times the height of the Galapagos, which is y. Now that I have my equations, I can solve. So it looks like one variable has already been solved for, so I'm going to use substitution here. And I'm going to replace the x with 22 plus 2y every time I see it in this first equation. So that means I'm going to say 22 plus 2y plus y is equal to 169. So all I did was just take this, replace it in here with my parentheses. But I don't really need the parentheses in this case. I can treat them as if they're not there, because I don't have any negatives happening. It's all positive, so it can all just be added together nicely. So I'm going to combine my like terms. I have a 2y and a y on the same side. So together that is 3y. And now I want to subtract 22 from either side. And I get 3y is equal to 147. And then when I divide by 3 here, y is, I don't know what that is, so I need to get my calculator. But then once we get the y, we can plug that back in to find our x, and then we will have finished this problem. So that's 49. Okay, so when I divide by 3, it gives me 49. So what I'm going to do now is I'm going to plug that back into, let's plug it into this equation right here, because it's already solved for x. So that means I'm going to type 22 plus 2 times 49 all into my calculator, and that's going to give me the value of x. So I get 120 as my x value. So that means the emperor penguin is 120 centimeters and the Galapagos penguin is 49 centimeters. And that really makes sense because it tells us that the emperor is the tallest and the Galapagos is the smallest. So if you had something that was not that and your Galapagos was actually bigger, then you definitely know that you made a mistake there because that goes against what it was telling us. Okay, I'm going to show you one more problem. So I know you don't have notes, but we're not going to move into the day 2. So maybe cross out like this problem on page, 18? Kind of cross this out and just write your notes there for this problem. Which one? This one. Yes. So I want us to look at number 3. This is going to help you with the number 4. You're going to have to do number 4 on the homework. So I want to talk about number 3 because we haven't done one like this. So I want to make sure you have all the possible types to help you with this homework. Okay? So the sum of the digits of a certain 2-digit number is 12. When I reverse the digits, I decrease the number by 54. What is the number? So I'm trying to find a 2-digit number because it tells me the sum of the digits of a certain 2-digit number is 12. So I know I'm dealing with a 2-digit number. I can call that number xy. Because remember, you can plug in any number 1 through 9. Or I guess 0 through 9. No, just 1 through 9 for x. And then 0 through 9 for y. Okay, so that's what I'm thinking. XY is my number. I don't know what the first digit is, X. I don't know what the second digit, Y. But it does tell me that the sum of those 2 digits is 12. So that means if I add X and Y together, it should equal 12. So I'm kind of limited already to the numbers here. And so you could maybe go about a guess and check method, maybe. But I think one of the better ways to think about this is with algebra, especially if we started to talk about what is a 3-digit number, so on and so on. That's kind of a harder thing because you would have 3 variables there. We're not there yet, but just getting into the practice of setting up your equations is important. So it says you reverse the digits, you decrease the number by 54. So if our original number is xy, when I reverse, it now becomes yx. And so what that means is I need to figure out how am I representing this number? What even is our number? What is a 2-digit number? What does that mean? So we kind of have to think about how would you express 32? Like in terms of breaking this down, and I'm just picking this random number. It's a random number out of nowhere. If I wanted to kind of break down 32, and you used to do this whenever you were younger, I can say that what I'm talking about, the number 3 is talking about the number of 10s that I have, right? And the number of the 2 is talking about the number of 1s that I have. And when I add those 2 together, that gives me the value of that number, 32. And so if I said I wanted to break down 46, you would tell me, oh, you have 4 10s and 6 1s. And together, that is 46. That's why we put those numbers there. And so when we're talking about decreasing the actual value of a number by 54, we need to really break down and think, okay, well, I'm decreasing it by 5 10s and 4 1s. So I somehow need to incorporate that and break down this xy in order to set up my equation the right way to express decreasing by 64. So if I want to break down xy, x is the number of 10s I have, y is the number of 1s I have. So if I really wanted to make that look a lot nicer, I can call this 10x plus y. So then, if I want to talk about the value of yx, the reversed, I can say y is the number of 10s I have, and now x is the number of 1s I have, or 10y plus x. So if this is my original, this is my reversed, I'm saying when I reverse the digits, I decrease the original number by 54. In other words, you can say the reverse is the original number decreased by 54. So I'm going to write it exactly as I'm saying it. The reversed, or 10y plus x is equal sign the original 10x plus y decreased by 54. And so this looks like a crazy mess right now, but we want to move all of the x and y's over to the same side, just like this, and it's going to look a lot nicer, right? Because we always want our x and y's to be over on the, what side is that? I'm losing my mind. The left, whenever we are dealing with, when we're wanting to solve by elimination, which is kind of my point. I want to solve by elimination here. So I'm going to subtract 10x, I'm going to subtract the y from this side. So I'm going to subtract 10x here, subtract the y here. So this all cancels out. I'm left with negative 54. And 10y minus 1y is 9y. And then x minus 10x is negative 9x. And so what I can do now is I can simplify all of this because my 9's actually go into all of this. So if let's divide by maybe a -9. Because I don't like dealing with negatives, so if I can just cancel out a lot of these negatives, then I'm doing good. So when I divide by -9 here, I get negative y plus x is equal to 6. Or I can rewrite that as x minus y equals 6, which looks a lot nicer than that situation right here. Okay, so I now have my two equations. I'm going to kind of move down into this area here because I'm running out of space. So I'm going to stack my equations up now that I have them. And I can just solve by elimination. So once we get to this step, it's super easy. But I know making that connection from here to here is hard. So that's why I wanted to go through it once with you, give you the layout, so that way you can move on to number 4. So when I solve by elimination here, I add down, so 1x plus 1x is 2x. My y's cancel out. 12 plus 6 is 18. That gives me x is 9 when I divide by 2. So whenever I plug this back into one of the equations here, 9 plus 3 is 12. That is true. So our y is 3. So I can write that over here. Y is 3. So therefore, xy, my original number, is 93. Okay. So that answers this question. And then I want to talk about number 4. This is one of your homeworks. The only thing that you have to realize is everything else is the same, except this time it tells you the numbers add up to 17 and not 12. So you would replace the 17 here for 12. Then you would increase the value by 9 rather than decreasing by 54. So you would change this minus 54 to a plus 9. That's about it. That's really the only difference. So if you can set that up similar to this and just fix those numbers and then solve, you're good. So your answer would just be the number that you get for that one. Okay, but if you have any questions, please let me know. Please email me. I'd be happy to answer or set up a Google Meet. And hopefully this video uploads and works better than the other one.